Hello, my name is Jean Marie Hartman. I'm a professor at Rutgers University, and I'm making this recording to give you background about the watershed poster you've been given by the Lower Raritan Watershed Partnership. A watershed is an area of land that drains into a body of water. The watershed divide is defined by the area topography, with the highest elevations defining the boundary of the watershed. In the U.S., the largest watershed is the Mississippi River. It goes from the highest elevations in the Appalachian Mountains to the highest elevations of the Rocky Mountains and drains into the Gulf of Mexico through Louisiana. All the lands of the U.S. can be divided into 21 major hydrologic unit codes or drainage basins. For example, these include the Mississippi River, the Colorado River, and New Jersey's Raritan River. New Jersey is divided into 20 watershed management areas. Watersheds can be defined by their hydrologic unit codes, or HUCs. These codes are used to specify watershed regions and subregions as determined by the U.S. Geological Survey. This slide shows the Raritan Basin, which includes 3 watershed management areas and about 1,100 square miles. Your high school is in New Jersey's Lower Raritan Watershed Management Area, which is the darkest area on this map. Watershed management is the practice of protecting and improving water quality, soil, and other natural resources in a watershed. The Lower Raritan Watershed is within the Raritan Basin and is a HUC 10. That means that it's defined by a 10-digit numeric code. Multiple smaller HUCs then make up the HUC 10. Some examples of the smaller areas within the Lower Raritan Watershed include Peters Brook, South River, Machaponix Brook, and Manalapan Brook. Within a watershed, the distribution and flow of streams is important in defining boundaries. Stream order characterizes a hierarchy of stream branches. For example, in the graphic on the right, a first-order stream is the small stream that drains land and does not have another stream that drains into it. The order of a stream is increased when 2 streams of the same order come together. In the diagram, notice how the order changes when 2 first-order streams meet. So a water body is considered a third-order stream when 2 second-order streams meet and continue flowing. On the watershed map for the Lower Raritan, you can find different kinds of lines. For instance, there are gray lines that represent highways and brown lines that represent municipal boundaries. In the enlargement on the right side of this slide, A points to a dashed line that represents the boundary of a sub-basin. B points to an area where there is a reservoir and the waterway is particularly wide. And C points to the location where the Lawrence Brook goes into the Raritan River. The land that drains into a stream or river influences the water quality and quantity in the waterway. This diagram shows that infiltration decreases and stormwater runoff increases when we develop land. This means that when it rains, streams in cities carry more water and are deeper than if the land was forested and able to absorb or infiltrate the precipitation. Thus, stream depth and the chance of flooding increases in more developed areas. Let's go through this diagram from left to right. In the first graphic, a natural ground cover is represented, and about 10% of the precipitation runs off. In the second graphic, a suburban area is represented, and in these cases, about 20% of the precipitation runs off. You see another increase in the more dense residential area in the third graphic. The fourth and final graphic represents a very urban setting where there is 75 to 100% impervious surface. Here, over half of the precipitation runs off into adjacent streams or rivers. Impervious surfaces include parking lots, buildings, highways, or any land use that does not allow water to infiltrate into the soil. As you could see from the previous diagram, as an area develops from natural lands to suburbs to cities, the percent of soil that is covered with impervious surfaces increases. This results in more stormwater draining into waterways. This map shows areas where the waterways are most highly degraded in the Lower Raritan and indicates there is only one subbasin where the streams and brooks have little or no impairment because of low amount of impervious surface. Impervious surfaces cause more water to run over the land faster and to pick up more pollutants from the land surface. As a result, there are more pollutants like sediments, oils, and nutrients from fertilizers in our waterways, causing water quality to go down. You may see this as muddy water or water with an oil sheen on the surface. The important thing to remember is that water quality of a portion of a stream is determined by the water quality upstream and by the land uses that drain into a section of the stream. In addition to pollutants that may be washed off the land as part of stormwater runoff, there are additional historic sources of water pollution. One example is the known contaminated sites shown on this map. When a site is found to be contaminated, it is reported to the New Jersey Department of Environmental Protection. A plan for cleaning the site so it will not contribute to water pollution or be unsafe for people to use is then developed and approved through the New Jersey DEP. The white dots on this map show points where contamination removal has not yet been approved. After a site meets safety standards, it is given a remediated action permit that may define what future uses are appropriate. The purple points refer to this condition. The green points are ones where there is an active remedial program in progress. On the poster, you will see other maps that show discharge permits, which are required for each permitted pipe that discharges polluted waters into a stream or river. In order to make sure that water quality is being maintained or improved, monitoring is necessary. Water monitoring is conducted by different groups, including scientists from New Jersey Department of Environmental Protection, from the U.S. Geological Survey, Watershed Management Area, employees and volunteers, schools, universities, and citizen scientists. This map shows points at which one type of monitoring, biological monitoring, is being conducted regularly. Some monitoring is part of specific research projects, while other monitoring, such as that shown here, contributes to a long-term record of water quality in our streams and rivers. The drinking water for our area is obtained mostly from local reservoirs, the Delaware Raritan Canal, and other surface waters. Having high-quality water in our watershed allows for local sources of drinking water to be used, instead of spending money and energy to import water from further locations. Not only is better water quality beneficial to humans for consumption, the level of water quality also determines what can live in the water. Better water quality allows for fish and the things they eat, and if the water is clean enough, the fish can be harvested for human consumption. So what can help improve water quality? One important thing that helps is keeping the land that is adjacent to a stream or river undeveloped and intact. The forested areas adjacent to a stream or river are known as a riparian zone. These zones act as buffers, protecting the stream from harmful stressors such as stormwater runoff, pollution, human interactions, etc. We can all also give a hand by not littering in the streets, because the litter that ends up in the streets eventually goes down through the storm drains and ends up in our waterways. I hope that you'll find this information useful in developing programs to use the poster you were given by the Lower Raritan Watershed Partnership. Thank you.